Alright guys, what's up? We're moving on day 2 of chapter 12. The homework, I got the homework from an Algebra 2 book, but it works the same. I'm just labeling it as worksheet. I don't know, just cause. But yeah, it's from an Algebra 2 book, so yeah, good problems though. Okay, we're gonna move on. Fundamental counting principle. The number of possible outcomes in a sample space can be found by multiplying the number of possible outcomes for each event. If event M can occur in M ways and is followed by N. It's a lot of convoluted things. What I want you guys to understand is just understand is M times N ways. Okay, the idea is M times N. Essentially what's happening here is the bicycle manufacturer makes 5 and 10 speed bikes in 7 different colors and 4 different frame sizes. How many different bicycles? So the way that I do this is I create like little slots, right? Like instead of doing 5 speed can be one color, like let's say red, and then size small, right? Instead of doing that, because that's going to take forever for me to list everything out, I'm going to create slots. The first slot represents one type, 5 or 10 speed. The second one represents colors. The second one represents size. And what you're essentially doing is you're just, once you have your categories filled out, you just plug in like speed. How many different speed bikes are there? There's 2 different speed bikes, so 2 goes there. How many different colors can there be? Oh, there's 7 colors, can go there. How many frames are there? There's 4 frames, and what I'm going to do is I'm going to multiply them all together, because that's what the fundamental counting principle does, is just tells you to multiply them together. So that's so you just multiply, so it's 56. Like I'm not gonna write 56 ways. Like I'm not gonna like list out 56 of them. I just know that there's 56 ways. That's it. Colorado license plate, like the one shown, consists of 3 digits and 3 letters. Using this pattern, how many different license plates can exist? Okay, so the first 3 are digits. The last 3 are letters. I'm just gonna write 6 slots all together. How many digits are there for this first one? Well, there should be what? 0, 1, 2, 3, 4. Sorry, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9. There's 10 digits altogether, right? I'm assuming you could repeat. So how many digits can go in the second spot? 10. How many digits can go into this third spot? 10, right? Because they can repeat. And the digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 10 of them. Okay, the last 3 are letters, right? And what we do is we do the same thing. Like how many digits can go in this first, or how many letters can go here? Well, there's 26 letters in alphabet. Okay, I knew that off the top of my head. I totally did not Google that just now. This is 26. This is 26, and what we're gonna do is we're gonna multiply. So right here are the digits, and these are letters, and we could repeat. Right, we can repeat. So once we multiply them all together, let me get a calculator and do this real quick. 10 times 10 times 10. I should know that that's 1,000. God, I totally messed up. 26 times 26 times 26 times 1,000. So there's 17,576,000 ways. Now I'm gonna do the same problem one more time, right? Wait, we have 3 spots. Once again for digits and for letters. But what happens now is we can't repeat. Meaning if you already used it, you can't use it again. So the first spot, how many different digits can go in this first spot? It's still 10, right? Like you have all 10 to choose from. But in the second spot, because you already used a number, right? You already used a number, you actually have 9 left here. In the third spot, because you used 2 numbers, it's 8. So it goes down by 1 because you have already used 1 number up, right? It says no repeats. For the letters, it's 26, 25, 24, because you're using them. And all I'm doing is I'm multiplying all of these things together. So I'm multiplying all of these, and whatever your answer is the answer. Okay? All right, this next one's and versus or. Or I want you guys to think of in terms of addition. and I want you guys to think about as multiplication. Anytime you see those words, I want to do this or this, that means to add. If it says do this and this, that means to multiply. And can also be a then too. Then can be used for and. So just keep that in mind. That's going to come up later on. Or is add, and / then is multiply. LeBron is picking an outfit to wear for the day. He has 3 shirts, 6 pants, 2 jackets, 4 shoes, and 3 rings to pick from. He only has 3 rings. How many different outfits can LeBron wear if he can only wear one from each item? So once again, this is doing categories. And notice how it's using and, right? I'm doing this, and then I'm doing this, and then I'm doing this. I'm picking a shirt, and then I'm picking pants, and then I'm picking jackets, and then I'm picking shoes, and then I'm picking rings, right? I'm doing and. So it's multiply. So it's 3, because that's the shirts, times 6, because that's the pants, times 2, because that's the jacket, times 4, that's the shoes, and then times 3, because that's the rings. And we just multiply all these numbers together. So that's what? 3 times 6 times 2 times 4 times 3. God, I hope I did that right. Let me do it one time. 3 times 6 times 2 times 4 times 3. I got 432 ways. Pretty simple. Nothing too crazy. This whole thing is called a permutation. Okay? In a permutation, what's really important is that order matters. How you pick things. So essentially what I'm doing is I'm just selecting things. I have a group of things and I'm picking things out. Order matters. A prime example of order being important is when you're running a race, right? How many ways can 3 runners place in the top 3? So the first thing I do when I do a permutation in general, the first thing I do is I create spots. I know that there's 3 spots because there's 3 positions. And I have to fill those positions in with runners. So you have to figure out what is the bucket that you're filling. The bucket, here's the 3 positions. And what's going in the bucket? It's the runners, right? Because the order matters, because like runner A getting first is different from runner A getting second, right? The order matters there. When we were picking up, don't worry about that top one. That was fundamental. But because order matters, I'm going to pick spots. So how many people can get first place? Well, 3 people can get first place. How many people can get second place? Well, 1 person already got first place, so that means there's only 2 possibilities left, so 2 people. And how many people can get third? 1. So the answer is 6. There's 6 ways for this to happen. Right? Because 1 person's already got used up, used for a position, and then we go down the list. This is what is called a factorial. Right? A factorial, n exclamation. Don't say n. That was a joke, but it's hard to do jokes doing this video lesson. N factorial, right? It just means to multiply going down. And here's an example. If I do 4 factorial, that's 4 times 3 times 2 times 1. If I do 10 factorial, that's 10 times 9 times 8 all the way to times 3 times 2 times 1. Okay, and then 0 factorial is always 1. That's what a factorial is, okay? Your calculus should have it. It's read as n factorial. Don't read it as n excited. All right. There are 8 runners placed. How many ways can they get gold, silver, bronze? Okay, so first of all, you got to figure out what's the bucket. Where are you fitting people? How many buckets? Is it 8? Should I have 8 slots or should I have 3? That's the most important part. Should I have 8 or should I have 3? Well, I'm trying to place 8 into 3, so I should have 3 spots. I should have gold, I should have silver, and I should have bronze. How many people can win gold? Well, 8 people can, right? How many people can win silver? That's 7. How many people can win bronze? That's 6. So 8 times 7 times 6 would be kind of the move that you want to do right there. 8 times 7 times 6. So I got 336 ways. So this is called a permutation. Like what we did, it's this formula right here. I read it as n permutate r. Okay, n is like how many slots. R is things, how many things into slots. To be honest, when I'm doing a permutation, I don't really care about this formula. Like, the formula is good to know. Like, you should know the notation N, P, R. You should definitely know that that symbolism, but I don't memorize the formula, right? Like in this last problem, you know, it's 8p3. Totally messed that up. Sorry, and here, have them flipped. R is the slots, and how many into slots. Sorry about that. And permutate R. Okay. Like here, this is 3 permutate 3. Right? I make splots. I don't really use the formula. If you wanted to use the formula, you totally could. I'll show you an example. Like, I'm gonna do 8p3 right here by using the formula instead of making slots. So it's 8 factorial over 8 minus 3 factorial, which is 8 factorial over 5 factorial. And now if you actually notice, the top is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, right? The bottom is 5 times 4 times 3 times 2 times 1. But if you notice, things cancel out. 5, 4, 3, 2, 1s cancel out. So you have 8 times 7 times 6, which is essentially exactly what we have there. Right? If we were in class, this would have been like a revelation, a jaw-dropping moment that you guys applaud to, but we're not. So I'm going to move on. You just downloaded 5 new albums to your iPod. Oh, God, so old. And are eager to listen to them. Now, how many different orders? So number 5, you have 5 different albums on your iPod. Okay, so 1, 2, 3, 4, 5. Right? This is essentially, you want to listen to them all, so it's 5 permutate 5. I'm going to make 5 slots. I made 5 slots. Smooth, I know. How many albums can I listen to first? Well, I can listen to 5 albums first. How many albums can I listen to second? Well, I already listened to one first, so it's 4, 3, 2, 1. 20, 60, 120. Nice. 6. You take your iPod to the beach and select a playlist of 8 of your favorite albums. You'll be there long enough to hear 5 of them. How many different ones? Well, you got to make your slots. Well, this is 8 permutate 5. How many slots do we have? We still have 5 slots. How many can go in this first slot? Well, you have 8 albums now, so 8 times 7 times 6 times 5 times 4. Which is fine. So you just compute that out. So you have 6,720. Okay. All right, yes, that's about it that I have. Pretty simple. Next time we'll move on to something a little harder, but that's pretty much it. See ya.